Welcome to the first component of a four-part series on enzymes presented by OneSource Medicine. Enzymes are three-dimensional biological macromolecules which, when present, have the ability to speed up chemical reactions by many orders of magnitude. Note that I did not say enzymes are proteins. While it is true that most enzymes we think about these days are proteins, the further back we look along the evolutionary timeline, the more we see enzymatic functions being carried out by non-protein macromolecules. Specifically, I'm talking about RNA. According to the RNA world hypothesis, enzymes have been around longer than the very notion of proteins. Skeptical? I really can't blame you. However, you don't need to take my word, or even the word of the RNA world dudes at face value on this one. Instead, look at how proteins are made. We start with a molecule of mRNA making its way out of the nucleus to meet up with a flash mob of ribosomal subunits, which spontaneously assemble into a ribosome in the presence of mRNA. The ribosome then uses instructions provided by the mRNA to begin linking together individual amino acids, eventually forming polypeptide chains, which later undergo post-translational modifications to form proteins. But that's a different story for another day. Back to the polypeptide chains. These things are held together by hundreds or even thousands of peptide bonds, all of which are formed in chemical reactions catalyzed by the ribosomes. It sounds like the ribosomes are the real MVPs. I mean, if you acknowledge that most enzymes are made of proteins, then the chances are that ribosomes are legitimately your favorite enzymes. But what does all this have to do with the RNA world hypothesis anyway? As it turns out, ribosomes themselves are not proteins. In fact, that flash mob of ribosomal subunits comprising your favorite enzyme is actually a ragtag band of ribosomal RNA. But regardless of whether an enzyme is a protein or a specifically folded segment of RNA, its proclivity for increasing a reaction's rate hinges on the enzyme's ability to facilitate optimal conditions for the reaction in question. But what do we even mean by optimal conditions, and how would an enzyme go about facilitating these conditions? Tune in for part 2 to find out.